Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Murder Mystery by 3 Good 5 U. And here are the rules. Regular Sudoku rules apply. Place the digits 1 through 9 in every row, column, and 3 by 3 box exactly once each. Indexed little killers. Each arrow outside the grid has a unique index from 1 to 9 inclusive, given by the number next to the arrow outside the grid. So this number next to the arrow is the index of the arrow, and it's unique for each arrow. If given as a question mark, the arrow's index must be determined by the solver. Each line in the grid corresponds to exactly one arrow, and each arrow corresponds to exactly one line. So one of these lines is specifically related to one of the arrows, and it's only to one for each line, and each arrow is also only related to one. Now, what does this mean where they correspond to each other? Let the sum of the digits inside the grid pointed to by an arrow be the arrow's little killer sum. A line that corresponds to an arrow must, when read in some direction from one end of the line to the other, first contain the index of the arrow, then the little killer's sum's tens digit, then its ones digit. Which line corresponds to which arrow, as well as the reading direction for the line, may remain ambiguous. For example, if row 1, column 8, and row 2, column 9 are an 8 and a 9, so say this was an 8 and this was a 9, then the arrow with the index of 4, which is this arrow, would have a little killer sum of 17. And the line corresponding to this arrow would read as 417 from one of the ends of the line to the other. So say somehow we determined this was the line that corresponded with this arrow. Then this would have to be 417 or 417 in some direction, because we know that this is equal to 17. So the sum is 17. The index would be 4, obviously, and it has to read index, tens digit, and then ones digit in some order. It could be this way or this way. And that's only if we match it with that index arrow, right? So if it's a different line, obviously, then you could have, like, say it was this line, then this would be 417, etc., etc. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so I think these are for essentially the lines, right? So we're going to do 1 through 9 then on each of these, right? What do each of these add up to? Well, 1 has to add up to something with 1, and then we don't know what the next one is. It's questionable. 2 also ends up with 1, so this has to be 1 something. So actually it's 1 and 7, right? So it's 1 through 7 here. This is 1 through 7 here, because it could be 11. 3, we don't know. 4 is also the same. It's 1 through 11. It's 11 through 17. 5 could be 1 or 2, right? And it could be any of the digits in between. 6 is also 1 or 2. So it could be up to 24, but down to 11. 7 we don't know. 8 we don't know. 9 can be 1 through 4 in the tens digit, right? It could actually be 20 something. It could be 24 here and then 24 here, which would add up to 48. One of these digits is, what's the minimum? So this is at least, well, minimum's always 1, right? So for these sets of numbers, this can only one of these digits can be 1. Only one of these digits can be 1. So that's 1 1 here, 2 1s here, 3 1, 4 1, 5 1. You can have at most 5 1 digits in the tens place. Well, it seems okay so far. This is obviously 1 to what is the question? This could be 8 and 9 plus 9. So 9 could be 1, 2, 3, 4, 5 times here. One, two, three, four, 5 times. That's 45 plus 8 times 3. So it could be 6. And this is equivalent to, right? Because this is also 8 digits, 5 of which could be 9, and 4 of which could be 8. We do know these digits cannot be 1. That's all we know. These digits cannot be 1, and these digits cannot be 1. Hmm. So far we have 3 1s guaranteed. We also have a 1 1, right? Which line is the 1 1? It has to be either this line or this line. So we know one of these two is a 1, right? Either this is 1 and this is 1, or this is 1. So either it's 1 1 here, or this is 1 and one of these two is a 1, right? It could be even all 3 are 1s. So either this is 1 and this is 1, or this is 1 with one of these being a 1. Either way, this cannot be 1. And this cannot be 1, right? So the 1 has to be one of these, at least. And it could be both. This is interesting if this is 1 and 1, right? Is it though? It still could be 2. Hmm. Oh, this is interesting. So we know the largest this any of the arrows tens digit could be is 5 times 9, which is 45. 5 times 9, which is 45. Oh, this can never be 1, right? So this has to be at least 2. So this is 2 through 9. Obviously no 5. This is also 2 through 9. Um, we don't know about this. We don't know about this. I mean, it's still 2 through 9 here. It's 2 through 9 here, but the problem is that it's not, it's pretty limited to what that makes that. This can never be more than 6, right? Because again, well, it's also this one too. It can be at most what, 6, 8, 9 again. That's 17 plus 8, 9, which is 17 plus 8, 9, which is 17. Or 5 times 4, sorry, 5 times 9, which is 45, plus 8 times 3, which is 24. So 45 plus 24 is 69. So this can only be at most 1 through 6. 1 through 6 and 1 through 6. So this is at most 2, 3, 4, and 6, which means this cannot be 2, 3, or 4. It can't be 6 either, because it has to be adding up to at least one in the tens digit, right? And if it's 6 and 4, that would be 1, 0, but 0 is not a legitimate normal Sudoku digit. So all of these actually have to be 1 through 6, and these are 1 through 6, and this is 1 through 6, and these are 1 through 6, and this can't be 2, obviously. Um, so this cannot be 1. One of these is a 1, and one of these is a 1, and one of these is a 1, and one of these can be at most a 1. So that's 4 ones possible then, right? Therefore, only one of 5 and 6 can be a 1. Oh, interesting. If whatever number is here was a 1, that means 6 would also have to have a teen, right? Because it'd be at most 1 plus 8 plus 9. So I think that guarantees 5 has to be 2 at least. Right? Because if it's not a 2, the problem is is that a guarantee? Say 6 was a 2, right? If 6 is a 2, that would mean this would have to be at least 4 with 8 and 9. but then we would only have 1, 1, 2 ones, and a third one available. So therefore 5 would have to be a 2. And if 6 is a 1, well, we have 4 ones then, and this would have to have a 1, right? So 6 could be a 2, but everything else cannot be 1, right? So 5 has to be 2 here. This can no longer be 1. None of these can be 1. So 5 has to be a 2. If 6 is a 1, that means we have 4 ones, and 6 also has to have, this also has to be a 1. So therefore 5 has to be at least 21, 2, 3, or it cannot be 22. It could be potentially 22, maybe. So this is at least a 4 here, right? It has to be 4, 8, and 9 at least. So it's 4, 8, 9, 4, 8, 9. It could be 5, 7, 9, and 6, 7, 8. But either way, this has to have a 7, 8, or 9 in these spots. We know there's at least 3 ones, and if the 6 has a 1, it's one of those. It has to be here. So this has to be a 1 then. So this is a 1, which means this cannot be 1. One of these two is a 1. Neither of these can be a 1. So therefore, this can no longer be 1, 1. So this has to be the corresponding 1, 1. So this is 1, and this is 1. This cannot be corresponding 1. Okay. Okay, so we know this can't be 9, right? The corresponding one has to be 1, 2, 4, or 6 next to a 1. So this can only be 17 or 18. And this can't be 1. So it could be 2, 4, or 6. And the 6 could be potentially 1, 1, 8, and 9, right? If this is a 1. So this is 1, 1. Obviously this could be 1 through, this can't be 1. So this is 2 through 7. So this cannot have a 2 in this diagonal either. It could be 3 through 9. So this can't be 1 anymore because of that. Because it has to go 1, 1 that way. This can't be 1. It could be 21 here. This can't be 1. This can't be 1. This can't be 1. So 1 has to be one of these 2 digits. This can't be 1. This can't be 1. So 1 has to be one of these 4 digits. And then 1 has to be one of these 3. This can't be 5. So this corresponds to this 1, obviously. I'm going to make this medium, dark, green, pink, orange, red, yellow, and blue. Hmm. Okay, so 2 cannot be 11, right? If 2 were 11, actually, it still could be 11. Sorry, this could be 2, 9. So one of these 4 is a 1 also. The 4 can never be 8 and 9. At most, it's 6 and 9, right? Or it cannot be 7 and 8 because that's 7 or 8. So this is at 7. 4 is at most 1 through 5. This is 2, 4, or 6. 2 is also at most 15. So this is also 2, 1, 2, 3, 4, 5. Can it ever be 2, 2? I don't think so, right? Yeah, this can't. Any 2 has to be by itself as a tens digit. So this can never be 2. And in fact, actually, I don't think any other one can be 11 for the if you have a 1, right? Because all the lines are essentially, they see the tens digit sees the ones digit, except for this one, and this can't be 2, 2 specifically, and it can't have a 1 either. So this can't be 2, 2, it can't be 2, 2 this way. So there's no 2, 2 in any of the spots. Ah, this has to be the 6 then. Because otherwise it can't, 4 doesn't add up to 17 at all. Because we have a 7, 8, 9 pair. We have 2 digits that are from 7, 8, or 9 in box 3. Which eliminates this from being 8, 9. Similarly, 2 cannot be because this can't be 8 or 9 either. So this has to be 6. And it's either 17 or 18, which means this has to be a 1. This is a 1, and this is 17 or 18. So this corresponds to the orange. So then this is 7, 8, 9, and 7, 8, 9, right? If it's 17, this has to be 7 and 9. So then this would be 9, and this would be 7. If it's 18, so this can't be 6 here. If it's 18, so this can't be 6. Oh, that's interesting. So this one specifically has to be 4, 8, 9, or 5, 7, 9. In either way, this is a 9. So this can't be 9. I think this has to be a 9 also, right? So if this is 17, this would still have to be 1, 7, and 9. So this can't be 1, interestingly enough. One of these two has to, this can't be 1, so this is a 1 here. Huh. And this cannot be the ones digit, so one of these is a 1. It could be the 5, right? We know, actually, we know this is 21. The 2 cannot be 11, though. So this cannot be a 2 here. Interesting. Right, because you can't have 2, 1, 1 or 2, 1, 1 in any of these spots anymore. 14 can't, 4 also cannot be that way. So this has to be at least 4, 5, 6, 7, 8. 4 and 5 cannot have a difference of, that cannot be 4 or 5. So this, well, it could be 45, right? That's possible, I guess. This can't be 6. This can't be 6. Oh, one of them is 4, 5, and the other one's 7, 8. So it cannot be 4, 7. It could be 4, 8, which adds up to 12. It could be 5, 7, which adds up to 12. Or it could be 5, 8, which adds up to 13. So this is specifically 12 or 13. Okay. So this is something 1. And it's not 21, so it's not the pink one. This has to be 21 because it cannot, you can't have anything greater than 6 there, and this one has to be a 6 because there's 4 and 5, 4 and 2 can no longer add up to 17, so it has to specifically be the 6th one that's adding up to 17 or 18. So this digit is the same as, this digit is the same as that, which means it's one of these 3. This can't be 1. The 1 has to be one of those 2. The 1 can be any of these 3. The 1 here can be any of, oh, these 2. Well, this can't be 1. This can't be 1. This is a 3 with a 1. One of these is a 1 because this one can't be 1. This one can't be 1. This can't be 1 from here, and these can't be 1. So one of these 2 is a 1, which means this can't be 1. Therefore, this is a 1. We know then one of these is 21. So this can't be 1. One of these 2 is a 1, and the other one is a 2. So this specifically has to be 1 and 2, which means this can't be 2. This has to be 3, 7, or 8. We're not sure which, right? To add up to 31 or 41 or 61, which we're not sure of. Because this is the tens digit, or sorry, this is the index, this is the tens digit, and that's the ones digit. So there's only one 1 in 3, 7, or 8. 9 cannot be 1. It can't, it could be any of the other ones though. So one of these is pink. The other one we're not sure of. This is medium gray or it's green. And one of these is medium gray or green. This is... So then the remaining digits here are 2 and 3. Because we have a 4, 5, 7, 8 quadruple in box 3. So this is 2 or 3. If it's 3, it could be 40 something, or it could be 7 or 8. So this cannot be 6. This can't be 6. It can't be 12 either, right? If it's 12, where could that be on one of the lines? Well, it couldn't be, right? Because it would have to be 2, 1, 2. And this can't be 2, so that can't be 1, 2 here. These see each other, so therefore it cannot be 2, 1, 2. None of these can be 2, 1, 2. This can't be 2, 1, 2. So it cannot be 12 then even. So this can't be 3. So this is 4 or 6. So it's 41 or 61. Interesting. So these cannot be 2 then. They have to be at least 3, 4. Well, that's not necessarily true. So 2 through 6, well, we don't have that much. So where's 5 is the question. The 5 does not have a 1 in the middle. The 5 has to have a 2 in the middle, and this can't be 1. So, sorry, that can't be 5. So one of these has to be a 5, right? Because it has to be 5, 2, 1. So 9 also has to be one of these digits. Hmm. Oh, this can't be 1 either, right? Either this is 2 and this is 1, or... Sorry, either this is 1 or this is 2, which forces that to be a 1 and that to be a 5, right? So this can't be 1 ever, which makes this a 1. we should have most of the ones set, right? So it's one's either one of these two, one's one of those two, 5 is one of those. Hmm. Oh, that's interesting. Right, so one of these is 521, right? So 521, 521. The other one has a 1 in the middle, 2 and 4 on the outside, with 2, 3, 4, 5 as the other one. So it cannot ever have 15, actually. So it could be 2, 3, 4 on the outside. So there's 1, 2, 3, 4, 1, 2, 3, 4. Or this is, well, it can't be 2 here, so this is 3, 4 here. Okay. Not sure what that tells us. Um, so one of these is 3. Well, we know we have a 4 and a 5 and a 4 and a 6 as the tens digit. This also has to be, interestingly enough. So it has to be 2, 3, and 4 on the outside here. Huh. Hmm. Hmm. Okay, so what's the most this could be, I guess? Still could be really high, so we don't have any limiting factors there. Hold up, we know this is 21, right? This has to be 21 because it's 489 or 579. This adds up to 12. So this has to be 12 then, right? Yeah, I think it has to be 412. So this adds up to, again, 21. This adds up to 12. So it's 33. Therefore, this must always add up to 12. So it's always 412. But we still don't know which one is the 2, 1. It could be 214 or it could be 213. Hmm. So I think either way, this has to be a 2 though, right? If it's 4, 1, 2, it's obviously one of these. Otherwise, it's 2. Similarly, this has to be a 2 also, right? I think so, right? Because, yeah, this has to be 1, 2, or 1, 2. So it's either 5, 2, 1, or this is 2, 1 something, or it's 4, 1, 2. And either way, the 2 has to be here. So this has to be a 1, 2 pair also. So this can't be 2. This could be 3 or 3. So the 2 has to be 1. Okay, well, we have a 1, 2, 1, 2 pair in row 3, which eliminates 1 and 2 from the rest of the row. So this must be 3, which means this can't be 3. That means this can't be 3 in here, so this must be a 2. Which means this cannot be 2. We know there's a 2 in one of these lines, therefore this must be a 2. And it's either 2, 1, 3 as this one, or it's 4, 1, 2 as the green one. So this can't be 2. This can't be 2. Therefore, this must be a 2. So this adds up to 12, which means there is no 6 here. So it's either 3, 9, 4, 8, or 5, 7, adding up to 12, because this has to be a 2. These can't be 2, so this must be a 2 here, which means this can't be 2. So we have all the other lines must be 3 or higher. So these can't be 2, and this can't be 2. Where are the 2's then? This is 1 and 2, so 2 has to be one of these cells. So 2 cannot be any of the remainders here, right? So 3 cannot be 30-something. 3 has to be specifically 4, 5, or 6 in the tens digit, right? Because all the 3 possibility lines have to, they all see each other. Well, actually, no, this could. So never mind. This could still be 3, 3. That is possible. This is at most 8 and 3, so that's 11 plus 8 plus 8, 9. Okay, so 8 and 3 plus 8, because this can't be 9. So that's 19. Plus 8 and 9. 19 plus 17 is 36. Plus 9 is 45. Plus 9 and 6, which would be 60, but the 0, the ones digit, would not be. So whatever this one is can only be 5 to start with. Oh, this is a 2. So this could be 2 plus 8 plus 9. So that's 19 plus 5 at most. 24 plus 8 plus 9. 41 plus 8 is 49. So this is at most 40. this could still be 60, and this could be 50 here. Obviously, the 9 could be 40 something also. Hmm. What else are... This can't be 5, therefore this can't be 7 here. The remaining digits here are 4, 5, 7, 8. 4, 5, 7, 8. Let's see. This is 3, 4, 5, 7, 8. This is 3, 4, 5, 7, 8. And this is 3, 4, 5, 7, 8. 3, 4, 5, 7, 8. Well, this can't be 5. 5 cannot be here or here, so 5 is one of these 3 digits. 3 cells, sorry. 5 is also one of these 3 cells. This is 3, 4, no 5, 6, 7, 8, 9. Oh, wait. 2, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8. So that was 69 at the largest. It could be 61, though. No, it can't. So again, this is at most a 1 9 here, a 9 here, a 9 here, but this can't be 9. And this can't be 9 either. So a 9 could be here, here, and here. So that's 3 9s. That's 27 plus 1, which is 28. Plus 1 8, 2 8, 3 8s, 4 8s. So this would be 9 times 3, 28. Plus 4 8s, which is 32. So 28 plus 32 is 60, but 0 is not a legitimate digit. Therefore, we can't have 6 in the 6th spot anymore. So this then has to be 4. Because we can never have a 6 anymore in any of the arrows. Because this 2 forces this to be, and this 3, 4, 5, I think, forced it to be 40 something. This was always 40 something. Having a 6 here even still limited to 49 to 59 because this had to be 3 at most. So this has to be 4, which forces this to be a 9 because it has to be 2, 1, 3, right? So this is 3 or 4. This is 3, 4, 5. We're not sure which, though. The rest of this has to be 3, 6, 7, or 8, right? We know 2 is one of these two digits. The rest of these digits are 3, 4, 5, 7, 8, or 6. This is 3, 4, 5, 6, 7, 8. So either 3, 7, or 8 is equal to 41, but we don't know which one that is. So this is a 9. Add up to 13, because it can't be 12. This can't be 9, which means this cannot be 3 to add up to 12. We have 2, 3, 4, 6, 7, 8, but this can't be 2. Okay. What other things do we have? So either this is 7 or 8, which adds up to 43 or 53, or this is 3, which adds up to 44, 45, 54, 50. It can't be 50, 44. It could be 45, 47, 48, or 54, 57, 58. Hmm. What are the maximums in general that you can have for these diagonals? Combine, if you combine everything, right? We know there's at least 30. Actually, yeah, you could potentially include the 9 here also, right? We know there's at least 1 4. There's at least 2 4s, right? And the other ones could be 30 something. So at minimum, if you have a 4, a 4, a 3, and a 3, that would have to add up to, well, you can't have a 1 or a 2. You can have a 41 here. And this could be 43 this is at least 43. This can't be 32. So this would have to be at least 34, I think, right? So we have a 41, we have at least a 43 here. This could be 32. So 41 plus 43 is 84 plus 32. 84 plus 32 is 116. And this is 34 at least, which would be 150 then total. So that's the minimum we can have. Well, actually, no, it'd have to be 35, right? Because it'd have to be 151. So what is that then as a possibility? Okay, we're going to have to, I'm just gonna mark these in general. And then these. Okay. Well, what does this add up to in general? Or what could it add up to is more the question, right? So this could be these 5 plus these 4. I think should be higher than the minimum. This is 12. We know for certain. This is 12. This has to be... This can be at most 1, 3, and 8. So that's another 12. 24. This is also 24. So that's 48. This is also 24. So that's 72. This is also 24. 96 plus 4 is 100 plus 2 is 102. This could be 6 through 9. Oh, this can't be 9, this can't be 9, this can't be 9. This has to be a 9. Actually, that's pretty useful, I guess. Maybe. Oh, okay. Well, where's the 9th spot here, right? The 9 has to be somewhere, right? But this is not, because it doesn't have a 9 at the end. It has a 9. We see a 9 there. This cannot be, because 9 has to be either here or here, because this adds up to 13. And this can't be 9, and that can't be 9. This is obviously the 1. These are the 2, 4, or 5 indexed lines. Well, and this can't be 9 because of this 9 or that 9. And this can't be 9 because of the same one. So this must be the 9 then. This has to be 9. Which means this cannot be 9 and 3 here. So this must be 3 or 4 here. This can't be 5 or 2 or 9. Excuse me. It still could be 3, 4, 6, 7, or 8, though. Okay. So 9 cannot be any of these. That means one of these 2 is a 9. Any of these 5 could be a 9. Any of these 4 could be a 9. Technically, this couldn't be 6, 7, 8, 9, because that would have to be 9. This would be the 6, and this would be 7, 8, 7, 8. But we know there's a 7 or 8 there. Okay. This can no longer be 9. So this is at most 6, 7, 8. But that doesn't limit things. We were still at like 100 and... It was a lot. This was 102 right here. Right, so this was 102. This is 30, 30, and 30, so that's 160 still. Sorry, 190. Okay. This can no longer be 6, right? Um, hmm. Ah, if this is 4, this would have to be 5 and 7 to add up to 12. But that would eliminate all possibilities for this cell. So this cannot be 4 then. This has to be a 3, which means none of these are 3, which forces we have a 6, 7, 8 triplet in box 7, which eliminates 6, 7, and 8 from the rest of the cells in that box. So this is a 3. This can no longer be 3. Therefore, we know 9 has to be 30, but none of the others can be 30. They all have to be at least 45. These can't be 3 anymore. So we have a 6, 7, 8 triplet. This has to be then 4, 5, or 9. This is 4, 5, or 9, but it can't be a 9 because that's 9. Therefore, one of these two is a 9. This is 4, 5, which makes, and this has to be 4. One of these two has to be 4 or 5, which means the rest of the box cannot contain 4 or 5, so this can't be 4 or 5. This has to be 7 or 8 here. Interesting. Well, that limits things here. Therefore, this must be 6. And 3 has to be one of these 3 cells. The rest of this cells actually is 3, 4, 5, 7, 8. 6 is, this can't be 4 anymore, which means this can't be 8. We now have, oh, interesting. This is a 7, 8. This is a 7, 8. So we have a 7, 8, 7, 8 pair now. In row 1, which eliminates 7 and 8 from the rest of the row. This becomes 4, 5. So now we have a 4, 5, 4, 5 pair in row 1 and in column 8. So the rest of the row and the column cannot be 4, 5, which means this is 3, 9 specifically. This has to be, we also have a 4, 5, 4, 5 pair now in row 2. So the rest of the row cannot be 4, 5. So this is 7 or 8. And we have a, therefore this is 2 with 6, 7, or 8 as the possibilities. So this cannot be 3 or 4. This can't be 4 or 5. This then has to be 6, 7, 8, or 9 here. Okay, this has to be 6, 7, 8. Okay, we're going to remove the reds for now. Well, It's actually, that's still pretty useful, I would say. Oh, that's interesting. That's a 3 at most. Ah, this has to be 3, and therefore the 3 has to be 45 or 54. Because this can no longer have a 7 or 8 on the other end, which means it cannot be 7 or 5 with a 3 at the end. So this has to be specifically the dark. So this is 45 or it's 54. We're not sure which. The 9 is 36, 7 or 8. One of these is 41. We don't know what the other one is, though. Oh, This is 7 or 8 also. We have a 6, 7, 8 triplet in row 7, which eliminates 6, 7, and 8 from the rest of the row. This can't be 7 or 8. It must be a 4 or 5 here. Don't know if we have anything else. These are smaller now. These are not. Interesting. Well, no. This could be 9 and it still could be 6 here. That's fine. But this is at least, at most, 5 and 8. So the 9 is 36, 7, or 8. Not sure what that tells us. So A, this is B, right? This is the corresponding 7 or 8. So this has to be A also. Which means one of these is A. We're not sure which. One of these is A. This can't be A. A has to be one of these two, which means A is one of these two. So this is B. This is B. One of these two is B. Oh. This is B and this is A. That's a 7, 8, 7, 8 pair in column 9, which eliminates 7 and 8 from the rest of the column. So this is 3, 4, 5, 6, 3, 4, 5, 6. So B has to be one of... B is one of these two. A has to be one of these three. So this is B. A is one of these three, obviously. A can be any of these three. B is one of those two. A has to be one of those three. The remaining digits here. Oh, this can't be 4. The remaining digits here are 3, 5, 6, 7, 8, and this can't be 5. This is 3, 4, 6, 7, 8. The B has to be one of those three, which doesn't tell us very much. Okay. If this is 5, 2, 1, this has to be 4, 1, 2, right? So this one must be then the 2, 1, 3. So this cannot be 3 in that case. Otherwise, if this is not 5, 2, 1, this would have to be 5, 2, 1, which means this is either 2, 1, 3 or 4, 1, 2. Which would make that a 3, so therefore this could not be a 3 then, either way. So this can't be 3 either way, but that doesn't really help us much. The A corresponds with, sorry, the B corresponds with this, which means, well, let's make that a Y. The A corresponds with that to add up to 12. So this makes it as Z. So this is B and Y to add up to 12. This is A and Z, which adds up to 12 also. So this must be then the Y, and the Z must be one of these. Both Z and Y are here. We're not sure which one's which. I'm not sure if that's useful. Let's see. So one of these is 41. The 3 is either 45 or 54. The 9 is 36, 37, or 38. And the other one we don't know. It's pretty broad. It could be anywhere from 42 all the way up to 58. We do know these two add up to 12. This can add up to at most 12, so that's 24. One of these has to be a 4 or a 5. It's with 7 or 8. So it could be at most 5 and 8 here, and you could have a 7 here. So again, we have at most 24 here, 7 and 8 with 5, which would be 20. So it's 44 at least, at most here. Oh, this is 5 digits too. It's 44 for that. This can be 9, 5, and 8, which is 22 at least. So it's 66. Sorry, at most. 22 at most. 66. This could be 9, 8, 9 total. Oh, I must have missed that other one previously. Hmm. Um, 18 plus 8 is 26. Plus 66 is 102. Hmm. Or we just don't include. Hmm. Similarly, this cannot, the cell cannot be a 3, right? Either this is 213. If this is not 213, well, then this one has to be 213, which means either way, this can't be a 3 here. But that doesn't really tell us very much. So, hmm. Hmm. Okay, we know again this has to be 36, 37, or 38. Uh, can this ever be 2 then is kind of the question, right? Probably 2, 5, 8 adds up to 15. And you could have 6, 8, 9, which adds up to, yeah, 23, which would be 38. Hmm. Hmm. And if it were 2, it would have to be obviously with 7 or 8. So this would have to be 7 or 8 here. Uh, hmm. Okay. Is there anything else that we can limit? Hmm. Hmm. So B could be here or one of these two. That doesn't help us very much, though. I guess this would be 61A. Hmm. We do know that one of these is a 9 here. Hmm. Is there a maximum amount this could be maybe is the question here. Right? Okay, so this is at most, it could be 5, 8, and 1. So that would be 13, 14. This could be at most 7, 8, and 5. So 14 plus 20, 34. This could be at most 5, 8, and 9. 5, 8, and 9. So you could have 14 plus 20, which is 34, plus 5, 8, and 9, which would be 22. So that's 56. Plus 5, 9, 8, which is another 22, which is 78. Plus 2, 3, and 9. That's 78. 92. That's still too big. That doesn't give us enough degrees of, I mean, that gives us still too many degrees of freedom possible. Hmm. 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 What happens if we make this a 5? If this is 5, this becomes 4, which makes that a 3. which would make this also 4 or 5. So 4 would have to be, this would be a 2-4 pair if that were the case. Hmm. Hmm. Well, okay, so say this was a 5, right? So then this would be 2, 1. This would be 4, 1, 2. This would have to be 3. Which means one of these two would be a 3. This can no longer be 5. One of these would be 5, so that can't be 5, that can't be 5. This would be 3, so this could not be 3 then. Hmm. Is that helpful? If this is, maybe we should try if making this 5. So if this is 5, this is 7, this is 7, this is 8 and 4. This would be 8 and 4. This would be 5 and 7. So it would be 4, 5, 8 here. Will that change anything, really? I don't know. This would be 4, 9, 4, 9. This is 11. This is 11. This is 9. So that's 20. This is at most 12. So that's 32. This is at most. It's possible. That's not helpful. Right. This would be okay. So if we tried going down that path, that seems like it was fine. Right? This is at least, this is 11. This is 20 with a 9. This is at most 12, so it's 32. This is at most 17. So that's 49. And then this could be 7. Well, I have to add up to 54, so this would have to be a 5 then, which is still fine. So then this would be 4. This would be 5. That's interesting. But this wouldn't have to be a 5 though, right? This is what's saying it's the maximum amount really. The degrees of freedom we would have. Hmm. Hmm. Huh. What could it be? We know at least one of these is 7, 8. Hmm. Hmm. Oh, that's interesting, actually. So if this is 5, that would force this to be 4, which would force that to be 3. The only place for 5 now is specifically here. So this would have to be 5, not 3. We wouldn't celebrate because that's not 5 in the corner. This would be 4, this would be 5, this would be 3. Therefore, this could not be 3. These cannot be 3 or 5. This would be a 4, 6 pair, which would mean this is a 6. So this could not be a 6. This would have to be B. This would be a 6. Then in that case, this would be specifically B. This would be B. And one of these would be B. This would have to be specifically 3 and 5. Oh, that's interesting. So then this would have to be specifically 7 or 8, right? Because this could no longer be 7 or 8. This couldn't be 6, so this would be a 7, 8, 9 triplet. This couldn't be 4. This couldn't be 4. Ah, and we run into a contradiction. Because this could no longer be 2. So this would have to be a 2, but where would the 4 be? Okay, that's kind of convoluted, but we figured out that that can't be a 4 there then. Or sorry, this can't be a 5. So this has to be a 4, which makes that a 5. Which means one of these can't be 5. This can't be 5. These can't be 4 then. Um, Therefore both of these are 40. That's interesting. Hmm. So this could not be 4. This can't be 4 either. So 5 is one of those two, which we already said. This cannot be 2 and 3 specifically, but that doesn't really help us much. Again, this can't be 3 at all. Right, either this is 3 or this is 3. We're not sure which, though. Hmm. Uh, hmm. This can't be 2 with 3 there. So it can't be 40. Well, we're not guaranteed that the 3 is there. One of these is 5. So it's 40 something. Hmm. This is 12. Do we look at what the minimum is? I don't think that's helpful. Two, 6, 4, 12, 3, 15, 4, 2, 21, 28. Yeah, that's not helpful at all. Because we know it's 40 something. 2, 8, 9, 5. So 2, 8, 9 is 19, plus 5 is 24. Plus 7, 8. It's 39, plus 7 or 8 is 46 or 47. That's interesting. So 2, 8, 9, 2, 8, 9, 5, 7, 8. So this is 20 here. This would be 39. Say this was 2 and 8 here. Oh. Okay. That's actually one thing we figured out. Okay. So, maybe looking for the maximum on one specific diagonal is good. Maximum here is 2, 8, 9, so that's 19, plus 5. Let's try to make this a 2 specifically, right? So 2, 8, 9, 5, 8, and 2. Nope, that's still possible. Dang it. Yeah, this is 19 then. This would be 10, so that's 29, and then plus 5 is 34. plus 7 would add it to 41. So that's possible. Dang it. I was hoping that that would be the case. Well, if that were the case as as this was 2, this could be 7, this would be 5, this would be 4. 4, 1, this could be 7. So 4, 1, 7. Then that would be 5, if that's the case. Well, it wouldn't have to be 7 or 8 here. This could be the 8 here, and that would be 4, and that could be 5, right? So, okay, let's say then this was 7, this was 8. So this is adds up to 45. Again, this was 5, this was 9 and 8. So this would have to be 5 at most. 9, 3, 5. So 9, 3, 5 adds up to 17. This could be 8 and 9. 17 plus 8 and 9 is 17, 34. Say this is 7, 1, yeah, and 5. Well, the question kind of becomes, where is 3, right? Which one is the 3 indexed arrow? Could it be this one? Could it be this one? Or could it be this one? Oh, interesting. If this becomes 3, that's interesting. So then this would be 1, this would be 2. Obviously, this would be 1, 2, 5. This would be 4. So this could not be 4. This would not be 4. That would not be 4. This could no longer be 5 here. This would be 7, 8. So therefore, this would have to be a 4 here. That's interesting. Then what would this be at most? This could be still 8, 8. So 8, 8, 4, which would be 20, plus 3. So 23. Still could be 7, though. So then this would have to be 9 and 8. Well, this would definitely have to be 9. This could be 8. So you could have 8 and 8 here, right? And then this would be 8. So 8, 8, that's 23. So this would be 33. But then this would be 9. Huh. We run into problems here, right? What about 7, 7, and 7, right? I don't think that works, right? So this is 21. This would be 30. But then this would have to be 9. Yeah, so we run into a problem specifically if we try to make this 3. So if we try to make this 3, this becomes 1 and 2. This is 1, 2, and 5 for the 5, 2, 1 pair. These can't be 5 anymore. This must be a 4, which means this can't be 5. So this is 4 specifically. I guess it could be, can it be 8? So it could be 8 and 8, right? But the 7 can no longer be here because the A is the only 7 or 8 that can be here. So it could be not, okay, so this is 2, 8, 9, 3, 4. So this is 19 plus 15, and it would have to add up to 42 or 41. Well, if this is 2, then this could be 2. So it could be 42. Right, because this is 19 plus 20. Yeah, and this would then, well, no, this would be 42. And then this could not be 42. Okay, so that's why it's problematic there. So if we try to have it as 8, that doesn't work. If we try to have it as 7, that also doesn't work, right? Well, can you make 8 and 6 and 6, and this is 9? Because 5 is too little, right? If you try to have it with 8, 8, 8, and 5, that adds up to 20, 38, which is not possible for 3, 8, or 9. 3, 7, or 8 as the arrow. So this would have to be 9, obviously. What if we made this 8, 8, and 6? That doesn't add up, I don't think, right? This is 20, 32, and it adds up to 40 here. Right, which is not allowed. So we know specifically this can't be 3 then. Okay. Well, I guess that's useful. We now know this has to be a 3, so this can't be 3. And this can't be 3, and these can't be 3. So this is the 2, 1, 3. It's not the green one. These can't be gray then. Specifically because of what we figured out there. Can it be 4? Maybe. If this is 4, this is 5. This would have to be 4. And again, I don't think you could have 5, right? With 8, 8, and 8. That would be 20, 39. Nope. So this would definitely have to be... so this would be 4. This would have to be 9. Oh, well, one thing we do know is... because of the 3... this can't be 3 anymore, so this has to be 6. Which means this can't be 6, so this is specifically B. This can't be B, this has to be 4. So this can't be 4. This can't be 4, this has to be B. Oops, I don't know what I did with this. This has to be B. So this is a 6 here, because this can no longer be 6. This can't be 6. One of these must be 6. This can't be 6. So one of these two is a B. We're not sure which. So this can't be 6. This can't be 6. We have a 4, 5, 4, 5 pair in row 4. So it eliminates 4 and 5 from the rest of the row. This can't be 4, 5. This has to be 3, 6, 7, 8, 9. Which is still pretty broad. Mm-hmm. Again, I think this actually works fine if this is 4. This becomes 4, 1, 2. This becomes 1, 2, 5. This would have to be a 4. This would be B. This would have to be a 9. But I think this works, right? So this could be 8. This could be 8. And this could be 8. So this is 20. This would be 43. But one of them could be 6, right? So this could be 8 and this could be 6, and that would be fine. Yeah. So the problem that we ran into earlier with the 3 is that it never added up to 41. And the 42 we had eliminated this as a possibility for 42 here, right? Heck, this could still even be 43 over here, right? It just couldn't that we couldn't get higher than 42, and we couldn't get to exactly 41, which is why this could never be 3. Um, hmm. Oh, interesting. So what it could be now is 41 for these, or 42, 43, 46, 47, 48. That's still pretty wide. Um, okay. Whatever this digit is, the opposite, or the one that's not there, is here, which would mean this specifically cannot be the other one, right? So say this was 7, this was 8. This could no longer be 8 for whatever as this part, right? Because this specifically would be the 7 for 1. So this specifically has to be B, which makes this a 3. So these can't be 3 anymore. This can't be 3 anymore. This has to be B here, which means this has to be B, because this is the start of the other one, right? If he tried to make this the start of it, and it was 7, 8, it would be exactly the same as that 7 or 8. So that wouldn't work. So this has to be A. This is B. And that only works because we now know this is 6, actually. That's pretty convoluted. But I guess it works. B can specifically be, so if it's B is 7, this cannot be B, right? So it has to be 40, not 7. Similarly, if this is 8, this cannot be 48 here, right? Because B was B48. So this cannot be 8, and this can't be 7 specifically. What is this value is another question, right? This now we know is 3. So the B is the same twice. This is 10. So this is 10 here. The B can be 7 or 8. This could specifically be 8, 9. So then 8, 9 is 17 plus 9 is 26. This is 36. 36 plus... if B is 8... If it's 7, it's 50 at most. If it's 8, it's 52 at most, but that still gives us a decent amount of leeway. Maybe we do have to figure this out. B goes with Y to add up to 22. So this is Z. This is Y. One of these could be Y. We don't know which one these are. Hold up, can you ever have 54 now? That might be the better question to ask. This one can't, right? We already just showed that. You have 4, 9, 8, 9 here. This would be 26 plus 4 is 30, plus 3 and 3 is 36, plus 8 and 8 is 52. So it cannot be 454 here. Well, if this is 54, this is 4 specifically, this is 1, this could be 8, 9, 8, 9, 3, 9. Maybe that's possible. So this would be 12 at least, plus 9. Actually, can this ever not be 9 is maybe the question we should be asking. Can this be 2 now? If this is 2, you could have 8, 8, 9. Yeah, you still could have, okay. Right. Can this be 4 or 5? Well, probably. If this is 54, this is 4, 1. So this is, I think, the only one that could be 3, if that's the case. Right, because this adds up to at most 2, 8, 9. So that's 19 plus 5 plus 8 plus 7. This would again be 4. This would be 7. Actually, this would be 7, 9. So this would be 7, 7, 7, 21 plus 8. 29 plus 5. Right, so if this is 54, this would be 7. This could be at most 7 anymore. This is at most 7. This could be 9 at most 5. And this could be 8. So what would that add up to? This is 10 here, 21, 55. Oh. But any of them could be 6. So this actually could be. Dang it. I was hoping that that wouldn't be the case, but this is actually possible to be that number 3. Well, could this one be is the question. Well, okay, let's go down that path. Okay, so let's say this was 6 then, right? This would have to be 4, this would be 5. This would be 6. This is 5 at most, but it could be 9, 8 here. This would add up to 10, 27. Yeah, and this is just the maximum. So we would have many degrees of, a decent amount of degrees of freedom there. So this would be 10, 27, 39, 44. So we would have 3 degrees of freedom, which is still fine. Okay, so that could be that one then. Dang it. We know this is 7 or 8. Can this also be the opposite 7 or 8? Probably, right? We know this can't be 2 and 3, though. So you have 4, 5 with 7 or 8. That means it's 5, 8, 9 at most, which is 22. But this could be any combination of factors here, so this is fine. Hmm. We don't know which is which. Hmm. 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 This is very convoluted. Hmm. What does this have to... Okay, so say this was a 7. If this is a 7, this would be 5, this would be 4, this would be 8. So then this would be 7. This would be 7. This would be 8. Oh. Huh. That's interesting. Okay. Right. So this one has to be A or 6. Or this one has to be A or 6. So no matter what, this cannot be 6 then. Because it can't be A. This could be B here. So this could be B. But we don't know. A is one of these two, no matter what, right? This is 6 or A. So this cannot be A. This could be B also. Hmm. So one of these is A. This is A or 6. This is A or 6. Huh. And this is A or 6, interestingly enough. Huh. Oh, we also have, yeah, 7, a 6, 7, 8 triplet in box 4. So this can't be 7 or 8. Interesting. So this has to be B, which means one of these three is a B. And it could be any of these. One of these two is a B. One of these three is a B, obviously. So the Z has to be equivalent to one of these two. We don't know about this, though. Or this. One of these is Y, one of these is Z. Again, we don't know which one's which. This is Z, obviously. Hmm. Uh, hmm. Well, we do have a very limited amount for these now, right? This we know is separate. It has to be 36, 7, or 8. But the question is, what could this be? Is essentially the key question. Since we already have a 9, a 3, and at most 7 or 8, we know these add up to 12. This is at most 12. So that's 24. This 24, these 5 could add up to 35. So we have 24 plus 3 is 27, plus 35 is 62. 9 is 71. If this is 8, it's 26. That seems like it could very well still be that. This is A at most, though. Okay, so these add up to 12 at least. So this is 12. Okay, for this to be 12, it would have to be 8 here. So we'd have 8, 8. This could be 8. This could be 7 and 5. Whichever one this is has to be the same as that one. So this could be 5, 7, 5. So this would be 7, this would be 5. This could be 5 and 9. This is B, so this is 7. So this is 5 and 7 at least. Okay, so what would all of this add up to? So again, this would add up to 24. This is 20, 44. 35 at least. 79. 22. This would be 4. Actually, let's make it the other way, just to make it easier, or just to see what limits we have, right? So say that's 7, this is 5, this would be 8, this would be 4. So it's 54, we're saying. Then this could be 7 at most. This could be 58, so 5, 8, this would be 5. The y is only a 4, so that would be 4, 9 at most. This would be 7, this would be 8 at most. This would add up to, again, 26. 4, 7, 9 is 20. So 26, 20, 46. Plus 20 here. 66. This would be 23. 66 plus 23 is 89. Plus 3 is 92. And this would be at most 35. So I think we've shown this cannot be 54, right? This is at most a 7. This is at most 5, 8, 5, 4, 7, 9. This 4 would be is because it's a y, right? And we know that's the y. So this is 4 at most with the 9. I don't think it really matters, actually, because this has to be 8. Oh, did I miss that 9? Dang it. I think that actually brings it above what the threshold is. Right, okay, so 26, 46, 66. Oh, this can't, well, I don't know if that helps, but 66 plus 23 is 89. Plus 3 is 92. Plus 9 is 101. Yeah, we do have that 9. Dang it. So it could be 399. You could have 5, 4, 5, 6, 4, 5, 7, 8, 9. So that would decrease to 33. So that'd be 134 as the limit. But this would be 41. This would be 46. Right. Because this 7 is problematic here, right? We could make this a 2, but that would decrease the value by 5. Yeah, I think this is where we see the problem. This has to be 2, right? If this is 7. So therefore this would have to be 2. So this was at least 46. So this would be 46 plus 41. This is 46. This is 41. Which means this has to be 50, and this is 54. So this is at least 46. This is at least 54. So that's 100. This would have to be 141 in value for these diagonals. But we only reached, like, I think it was 135 or whatever. And if you made this a 2, that would decrease this to 2. But again, then this value would be less. So you can never quite reach that value if this is 5. So now we've shown the z and the a have to be 4. This has to be 4 and a has to be 8. So the a has to be 8. The z has to be 4. The y's have to be 5s. And the b's have to be 7s. So these can't be 7 anymore. These can't be 7 anymore. This can't be 8 anymore. This cannot be 4 anymore. This can't be 5 anymore. And this can't be 7 anymore. So this can't be 8 because of the 6-8 pair in column 4, which eliminates 6 and 8. This can't be 8 anymore because this is 3, 5, 7. Okay, so this can't be 7 anymore. Interesting. Huh. Okay, we can delete all the corner stuff because it's not as helpful anymore. Okay, so this is 45. Now we know this is 45. Huh. Can this still be 2 is the question. I don't know. This is 10. This is 10. This is 20. This is 33. So either this adds up to 5, or sorry, 8. It could add up to 9. it could add it to 12. There's a wide variety. These can't be 7. So it's 36 or 38. Can this be 2 anymore? Maybe. 2, 4, and 7 adds up to 13. Plus another 7. So 2, 4, 7 adds up to 13. Plus 7 is 20. And 5 and 9 at most is here. So this cannot be a 2 then, which forces this to be a 2. Which means this can't be 2. So this has to be the 2 then. Right? Because we have 13 plus 7, that's 20. But this only adds up to 14 here, which would mean 34, which is not possible here. So that means this digit must be the same as this. So these digits must add up to 30. Right? So we're going to make that A, I guess. So this is A, that's A. The rest then is 30. So if this is 3, 4, 7, these would have to add up to 16. So this cannot be 3. This has to be 7, which makes this 3, which makes this 4, which makes that 3. These can't be 7 anymore. So this adds up to 18, right? So 7 plus 4 plus 7 is 18. So these two must add up to 12. Well, 5 and 9 can't add up to 12. 5 and 8 can't add up to 12. 5 and 6 can't add up to 12. So this must be specifically 4 and 8. Which makes this a 5, which makes that 9, which makes that 5. This can't be 8, so this is a 6, which makes that 8. This can't be 4 anymore, so this must be a 5, which makes this 5, 2, 1, which makes this 2, 1, and 4. This can no longer be 4. We don't know which one of these are. It could be either. This can't be 8. This can't be 8. This is now, what, 7 and 9? And this has to be... This can't be 9. This is a 6, which makes this a 9. Which means this can't be 9. This is A, which means this can't be A, so this must be A. This is the B corresponding. This has to be a 4. Okay, so then... we just have to add them up. We don't know what that is. We know this adds up to 30. This is... what does this add up to? This is 10. So this is a 6 or 8, and this is a 1. So this is an even number, and this is an odd number. Well, this is also an odd number. So it could be 41, 45, 46, or 48. So this is 18. This can't be 2 or 3. This can't be 2 or 3. 8 is 41. And this is 46 or 48. So this is 6 or 8. What is this? Okay, that's the question. This is 10. Then we have 30, or another 20 here, so that's 30. 10. Okay, so this is 10. This is 20, so that's 30. This is 37. And this has to be 7 then. Or 7 or 9, sorry. This is, yeah, so then we have, this is 7, this is 10, this is 20, so that's 37 already. This can only be an even number now, which means this has to be 9, which means the A's have to be 6, the B's have to be 8. And does this add up is the question, right? This would be 7. This is 8, 8, 8, 5, 5, and 2. So 24. This is 24. (26), 36 plus 5 is 41. So this, okay, so this has, so we know this is 9, obviously. So the 9 corresponds to here. This is the blue. This is the green. This has to be pink. This we know adds up to 41, so therefore this is the 8. Right. And this is 9, 3, 9, 3, 8. So it's 24 here. This is 8. 24 plus 8 is 32. 32 plus 6 is 38 plus 7 is 45. So this is 3. And this would be 7, which adds up to 46. And it looks like that all works. Whoa, this was a tough one. Wow. Crazy. Crazy stuff. Lots of math. Lots of math. Lots of math here. Wow. Yeah, it was really just trying things out and seeing where it sort of led to, right? Trying out this 3 here and then seeing what this added up to and finding out that it could not add up to 41. It could add up to 40 or 42, and it couldn't add up to anything greater than 42. Wow. Yeah, this was kind of tough. Very hard, supposedly, right? So, interesting. A very interesting puzzle. I thought it was going to be maybe a little easier, but it definitely lived up to the very hard billing. Probably because it just this part here and figuring out what they could add up to was kind of a pain, to be blunt about it. This was obviously the red, this was the yellow one. Yeah. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.